Hello. In this demonstration, I will show how to run PySpark on a Kubernetes cluster. I'll show you how to deploy to Docker for Desktop, the Kubernetes cluster, and deploy to Google Kubernetes Engine, the GKE. The emphasis here will be on deploying to Kubernetes. First, before it's deployed to Kubernetes cluster, you need to package up your program in Docker. And I have a prior video on how to package up your PySpark application into Docker. Once you have that Docker file set up, then you can deploy to Kubernetes. And I'm going to assume that you have your Docker file set up. Just see the previous demo to see how that works. So once we have our Docker file, then we can press the play button in this Cloud Code plugin, which I'm going to use. Or you can run at the terminal Docker build, and then you have your Docker image. Once you have your Docker image, now we're going to deploy that to the cluster. So as mentioned, there's a couple ways to package up your PySpark program. One is a Cloud Notebook. Another is doing Spark Submit, and with a bunch of zip files for your dependencies. In this video, I'm not going to demonstrate either one of these. I'm going to focus on using a Docker packaging of your PySpark program. And then once you have that, we're going to deploy that image to Google Kubernetes Engine or your Docker desktop Kubernetes. So if you want to know more about the packaging up your program as a Docker image, then see the prior video. I'm going to use the same project as I did in that prior video, but now I'm going to focus on deploying to Kubernetes. So here we're going to deploy to the Kubernetes cluster. The first one is the easy one for Docker for Desktop. The second one, it's just a few more steps because you have to make a Google project and set up an artifact repository, but happily this Cloud Code plugin does a lot of the work for you, which I'm going to rely on. Of course, all this can be done in the terminal using shell commands where you use kube control, but it's convenient to use a plugin like this Cloud Code plugin, which runs the Docker build commands in the kube control deployment commands. So I'm going to run this Cloud Code plugin from PyCharm. It's also available as VS Code. And also you can run the same sort of thing using, for Google anyway, using the Google shell. They have basically sort of a trimmed down version of VS Code in the cloud. And I'll have a subsequent video on how to do that. So just a reminder that I'm going to use this plugin, and it's an alternative to running the commands in the shell. And I find it simpler rather than typing out the commands. Of course, you can, do it in the shell if you'd like. So preparation here, you've got to have Docker installed and enabled the Kubernetes. For a Windows user, you need to have the WSL2 installed so you can run some commands. And you need to install Helm. And my prior video walks through how to do this. And we'll also do it with the Google Kubernetes Engine. I'll show how to do that there. We're going to install the Spark operator. I'm going to use the Spark operator instead of Spark Submit. And I've got a shell script that does the setup. It installs the Spark operator using Helm. And then it also installs the Spark account, which is necessary to run on the Kubernetes cluster. There's a minor fix, so I'm using this fixed version of 1.126. Hopefully when you see this, the issue will be fixed. But you can, I guess for the demo, I'm not going to use the Jupyter demo I have in the previous video, so I guess you don't need to install this fixed version. In any case, you need to install the Spark operator. So I'm going to walk through all these steps. So just a reminder of what we're doing here in terms of Spark on a cluster. Here's just an outline, which you'll see in the textbook. You've got your driver process and your Spark session as a way to communicate with the cluster, and your user code interacts with your Spark session, which you know as Spark or Spark context. And the cluster manager then is going to create executors, more executors, and more parallelism. And that's the sort of abstract conceptual description of how Spark spins off multiple executors to run code. And normally if I have 10 partitions, then I'll have 10 executors running. If you look at the documentation for Kubernetes and how it interacts with Spark, you get this diagram here on the right, and you have some sort of Spark submit. And when you submit to the Kubernetes cluster, there's a server that accepts that submit process, and then it's going to have a node, an executor that runs the driver, and executors that run your executors for the Spark process. So that's generally how it works. And so you can do Spark submit, and that's what's illustrated here. You have some sort of Spark submit process. The cluster receives the request. The partitions are mapped to tasks, and then you have it scheduled, and then it starts to execute. The driver interacts with the server and executes tasks on the executors, and typically each executor runs as a pod, which is essentially a process that runs on one of the nodes of your Kubernetes cluster. You know, this is a typical way in which you'll do a Spark submit. I'm not going to do that because it's a little bit more complicated. The simpler version of all of this is the Spark operator. I know there's more details here in the Spark cluster, but because there's more going on in the Spark cluster, there's less I have to do. So it simplifies deployment of our application on a cluster. You specify declaratively what you want to have deployed. Instead of doing a Spark submit, you have this YAML file that describes what your deployment should look like. And just there's some minor issues. As I pointed out, I'm using a patch version of 1.126. And anyway, you have a description of your what your Spark operator should deploy. That's your YAML file, the Spark operator YAML file. And then this gets submitted to your cluster. You can use Spark kube control to submit your YAML file. In my case, I'm going to use the Cloud Code plugin, which is essentially behind the scenes running kube control commands. Kube control is the terminal commands. The Spark operator interacts with the Kubernetes cluster. When you install the Spark operator, it actually gets installed as an application into the cluster, and then that Spark application works with the Kubernetes cluster to schedule your particular application. So that's part of what's represented in this drawing here. All right, so the Spark operator actually is deployed to the cluster, and then you deploy your application, and it interacts with the Spark operator to deploy your Spark application to the cluster. And as part of that, it spins off these driver and executor pods. So a little bit about how this file looks. Here's an example file. It's not exactly the one I'm going to use today, but here's a Spark operator. And you can see at the top, you have Spark operator and version of it. It's kind of Spark application. There's other kinds of scheduled applications in the Spark operator, but we're just using the Spark application. Give some description of the overall application you're deploying, and then you've got your driver and executor and some other details. Okay, so I describe a little bit of that here, just indicating this is Spark operator. You have some labeled attributes for your deployed application, so you can reference it. You can have a container, so this relies on Docker. So the whole point of this is you can have a Docker image, and it'll be built. So you need to have a Docker file and see the prior video for that. The idea is this Docker file contains all your program dependencies, and it's going to be deployed to the cluster, to multiple nodes and multiple processes. Then one of the key elements here for Python programs or PySpark programs is that we're going to have a path to our program. It's similar for Java or Scala. And I want to note that this is within the Docker image. This path is not a path on your local computer. It's a path in the Docker image. So when your program runs, the way this is set up is it has to have the Docker image, and in that image, on the local file system, somewhere there's a path to your program. And that's what will get started when the Spark operator and the things it works with wants to get everything started. It looks for this path and starts that program. There's some other details you can specify, ports and whatnot. The driver, in this case, some description of how many cores you want to use and how much memory, and similar for the executor. So a little bit about how to deploy to the Docker for desktop, which is the easiest. Assuming you have enough memory. I know I have some students that don't have enough memory, so they have to do a cloud shell or something like that. But if you have enough memory, this is the easiest thing to do, easier than deploying to Google Kubernetes engine or Amazon or whatever. All right, so here we go. So this is just demonstrating that I've got Docker for desktop running, and I've got an icon for Docker and an icon for Kubernetes. And also, at some point, you have to install the Spark operator, and it'll show up in the containers. So that's once you've installed it. In my case, I use this setup script to install it. So if you look at the Kubernetes Explorer at the right in PyCharm using the Cloud Code plugin, you can expand your Docker for desktop and see some of the elements in here. Right now, I don't have any executor. I don't have an application running, but I do see that I've installed my Spark operator, which you can see, and there's some other descriptions of this Spark operator within the cluster. So right now I've just got it's my Docker for desktop. I've got only one node, which is my computer. There's nothing on it. I did run a setup, which installed my Spark operator and also installed a Spark service account. So that's necessary to run your application on a Kubernetes cluster. This Spark account has to be set up. Okay, just a note about this description. Now, this is a little bit more detail about the Spark operator specification. There's a part for the executor and the driver, and a part for the executor. They're essentially the same in the sense that you specify a certain amount of vCores or virtual cores and a certain amount of memory. Remember, if you have a lot of data coming back to your driver, then half a gig of memory may not be enough. In this case, I've got 512 megabytes of memory. It's not that much, but I don't have much data coming back. So if you have a lot of data coming back at the end to your driver, you're going to have to increase that memory. Same with the executor. I've got a certain number of vCores, and then the memory, in this case, I've got a little simple program, but you might increase this to 8 gigabytes or something like that if you have a big process that's running. Your partitions are large and they take lots of memory. And then I'm using the dynamic allocation. So based on the number of partitions my program has, it's going to create a number of executors. If I have 10 partitions, in this case, I'll end up having 10 executors. Well, this sets the minimum number of executors when the process is started up, and I've got min as 1 and min an initial. And then the maximum number of executors right now is 2, but of course you can change that. So those are important aspects of your description for your Spark operator. So here we go. Here's some example runs. I've got the maximum set, and that's from the previous slide. I'm not showing that, but I'm changing this as a parameter, the maximum number of executors. And if I have a number of maximum executors 2, then I've got 2 here. I've got the driver. So I've got the driver plus 2 executors. If I set the max to be 5, then I've got the driver plus, 5 executors, right? It's pretty simple, isn't it? All right, next up, I can specify somewhere the number of partitions I have, either through a variety of mechanisms. The partitions are set, whether it's from reading the data and the data is naturally divided into some partitions, or I can repartition, or in this case, I'm using parallelize, but in any case, I end up with a certain number of partitions. And if in this case, I only have 8 partitions, and although I set my maximum number of executors to be 10, it didn't create 10 executors because, well, there's only 8 partitions. So you're limited by the number of partitions. If I only have 2 partitions and I have maximum of 100 executors, it's only going to do 2 partitions. So this is the base from which it determines how many executors you have. Your next limitation is the number of the partitions determines the number of maximum executors you have. In the next case is this parameter maximum executor is next up, and if it's a small number, I have got 100 partitions, but I only have 10 executors, well, that'll be my limitation. You can do other things too that mess things up, like I'll say maybe I have 20 the maximum number of executors, and it could be the case that the system wants to, and maybe I've got 20 partitions. Let's say I've got 100 partitions. Well, I can't end up with an error like this. As you can see here, these are yellow, and it's indicating those executors are not running. Why is that? Because there's plenty of partitions. I've got a large maximum number of executors, but I've got only a small cluster here. And in this case, it's going to say it can't schedule it because there's insufficient memory. So you're limited by, first, the number of partitions you have, second, by the number of maximum executors. Then also you're limited by your resources, whether you have enough memory, and also vCores. So just a reminder that when you allocate these executors, they're getting fitted into memory, and you can specify 1 million executors if you want, but if you don't have the memory for it, you're going to get this error. So just be aware that when you start up your program, if you get these yellow indications on this, and if you just run it the command line, you probably won't notice it, but you can go to your executor, your node, and describe it, and it'll tell you what's going on using kube control. All right, so let's see if we can get it to work. Let's do a demo, and first the demo will be on Docker for Desktop. I'll go through it in a second. There's a little bit more steps involved, as you'll see, for Google Kubernetes Engine. The extra steps are making a project and logging in and making sure the plugin is connected to the cloud and setting up an artifact repository. So there's a few more steps involved. So let's first do the easy one. Let's do Docker for Desktop. Here I am in PyCharm, and I've already installed the Cloud Code plugin, and I'm running Docker for Desktop. And let's just see that my Docker for Desktop is running. Yep, I see down here I've got everything green for Docker for Desktop and for Kubernetes. The plugin has this window view for Kubernetes Explorer. I expand it and expand my Docker for Desktop. Eventually you might connect to multiple clusters, and you'll see the clusters shown in this list. But now I don't have anything in there to speak of. I do have installed previously my my Spark operator, which I'll go ahead and install again. All the commands I'm about to do about deploying is going to be through the Cloud Code plugin, but know that in the background I could also do all this manually. I could do kube control in a terminal, config, get context, and it shows I'm using the Docker for Desktop context. I can do kube control, get some pods, and I'm getting all the pods here. And I can do Docker build and Docker and kube control deploy and all that, which is apply. I can do all of that, but why bother? Let's use the Cloud Code plugin, which does this for you. All right, so just remember, everything we're doing here can also be done manually using the terminal. All right, let's go ahead and look at our application. I've got a couple things to look at here. Starting with scaffold, it's going to be a file here that's going to deploy my application. Right now, locally, I'm going to deploy it as my K8 Spark. That's going to be my Docker image. I've got a Docker file. It's just, Docker file. And I've got a description of my application in Spark. Hello, that's my description for the Spark operator. So let's look at that. Here's my Spark operator. And it's sort of the usual file. It describes that I've got a Spark operator, some tags with respect to this, the same image, which is important. I keep track of my image name, so it'll change when we deploy it to the Google cluster. I've got a run file. It's inside the Docker image. I've got my driver. It has certain description of the cores and the memory. Same with the executor. And I'm using dynamic allocation, and here's the indication of the maximum number of executors. I also have a service for the Spark UI, which I'm not going to go into now. Right, anyway, that's my Spark operator. Let's look at the program itself. So I've got Hello Pi is my program. It's the default program that comes with Spark. You can see lots of demos. And it just calculates pi. I want to point out one thing we'll play with is the number of partitions. When we create some data here, we're going to parallelize this range of data 0 to n. So n will be could be a large number. And I'm going to split up that data using parallelize into some partitions. And I can set the number of partitions here. That'll be something to think about. Okay, next up, I'm going to look at the Spark Cloud Code configuration. And let me look at edit configurations. I did a bit of this in the other video. Just remind you, you can add a new Cloud Code configuration. And I'm going to run Cloud Code Kubernetes, and that's the configuration here. And you can give it a name. We'll specify a repository when we work with the Google Cloud. But for now, we don't need to do that. We have a file that describes where our different clusters are. You can use the one that's in this case in the Windows home, or you can use the one in Ubuntu home. And that describes our application. I'm going to go to the Spark Hello application, and I have a name here for it. And now I haven't specified an artifact repository. By default, it's going to choose the Docker. Then in the build, I have a scaffold file, which I showed before, which is the description of what needs to be done to build, and then the reference to the resource for the Spark operator. And then you can specify a few other parameters here about how much logging and so forth. So we'll leave it at trace, which is pretty complete. So the way this works is this is a Cloud Code plugin runtime configuration. The name is up here, and the other important thing to do is specify the scaffold file. The rest of it pretty much takes care of itself. As I mentioned, the scaffold file specifies where your Docker file is. Typically, it's called Docker file. And then the image name you want to build, because scaffold is going to use the Docker file to build the image for you. And also, you want to specify the Kubernetes resource for your Spark operator. But once that's all done, then I can go ahead and run my Spark hello command, which is going to run the Cloud Code configuration, and it's going to build using Docker build, and then run, deploy my application to the Kubernetes cluster, and then run it. So in a moment here in the upper right, I can see I got my driver, and it's working. And a few things that the Cloud Code plugin gives you, which is very nice, is I can right-click on this and describe, and also stream the logs. So both of these, of course, are found in kube control. You can stream logs and you can describe, but it's just convenient here. I can click on describe and get a description of my deployment. And you can see here a little bit about it. I can scroll up to the top and see the application, the labels, and so forth. And hopefully I don't have an error here about deployment. So this is important, this events. I'm going to look to see down here if there's some issue. I don't really care about this mount because I'm not using it. And it's noticed that I've already built this image before. So all that looks good to me. And the other thing I can do is I can right click on this, any one of these things, and stream the logs. And it looks like I missed the logs because it's already finished. Oh, I got it before it finished entirely. And you can see the logs that it actually did compute pi. So everything seems to work. Okay, the application is finished. I'm going to go ahead and press the stop button at the upper right, and everything's good. It's all done. All right, so just to do some demos of what I mentioned before, let's go ahead and first I want to note the number of partitions. I've got lots of partitions here, so that should not be a limitation. I'm going to go to my Spark here and change my number of executors to 10. So I just want to show that I can change that. And let's see what happens. I'll press my play button. I think before we only had 2. Now we've got 10. So let's see what happens over here to the right. We'll look for the number of executors to be 10. So if I expand my pods, I can see I always start with my driver. It seems to be running. And of course I could stream it, so maybe I should do that now. Don't want it to disappear on me. I'll stream the logs. It starts off with these executors being initialized. They go from different states being initialized and then to running. And I could stream the logs if this I wanted to. I could also describe each one of the executors. I think we should have 10. You can see they're 1 through 10 here. So let's see if they all turn from yellow to green, indicating there's enough memory and so forth. In this case, they are. It's had a half meg memory, and this computer seems to have enough. So it all seems to be working. I can look down here at my executor. There's some information about the executor, and then to the driver. And look at the logs from the driver. Hopefully it'll finish here with computing pi. Okay, it finishes. Seems to work. Now, let's break it because, why not? All right, so a couple things we can do to break it is let's go ahead and put some more memory in. Instead of half a gig of memory, let's do like 20 gigs of memory just for crazy, And I'm going to put my executors down to 2, and we'll see the error that this one gets. So let's run this. I'm going to stop the previous execution and run it. So hopefully we get an error that says insufficient memory when it tries to deploy my executor. Because I put it in the executor, you could also put too much memory request in your driver, of course. So there goes my driver. Seems to be green. I can stream the logs. Everything looks good. And now I should have it attempting to deploy my executor. And here we go, and I'll describe it. Oh, and it worked. How much memory does this computer have? Okay, so it worked, unfortunately. Let's see if the second one works. The second one probably will fail. All right, let's describe it. Yeah, insufficient memory. So I don't have 20 gigs on this computer, so the first one worked, and because I guess I got 10. And the driver takes a little bit, and of course PyCharm and all the rest of it's all running on this computer. All right, so that's one way to break it, is to request too much memory. Let's try something else. So it's helpful to understand what's going on so that when your program doesn't work the way you want it to, you can recognize the error. So another one I can do is request a bunch of cores. So let's do, I don't know, 8 cores, and that's going to be way too much. Let's do 4, and then a bunch of nodes, 10. That should be good. Okay, so in this case, I've requested what is amount to be too many cores, and maybe it'll get one to work, but some of the others will not work. So let's run this, see what kind of error message we get. In this case, we just get a silent error. It's not even started up an executor. Normally, I typically get a executor that says insufficient vCore. Let's see if we can get it to work with a smaller number. Looks like I failed to notice that I've got to set my core limits a little bit higher. It has to be higher than the core request. So let's say the core limit is 6 just for the sake of it, and we'll go back to 4 here for a core request. And let's see if it runs now and what kind of error message we get. Our Spark driver starts, we get an executor that starts. We have a number of other executors. They don't seem to be working, so let's look at it by looking at right-click and describe. Go down here, and it says insufficient CPU. Okay, so that's another way that things can fail. One last way in which we can be a little bit confused sometimes. I'm going to open up my program, and I've got a bunch of partitions here, but let's put it down to 2 partitions just to make it clear what's going on. So I only have 2 partitions. That'll be the number of partitions in my data. And then I look at my executors and I see I've got 10, and perhaps I didn't realize that my data only has 2 partitions. Now let me run it. I'm expecting incorrectly, I'm expecting it to have 10 executors, not realizing perhaps that my data only has 2 partitions. So let's go ahead and look over here to the right, zoom in. How many executors do I end up with? If I look at my Spark operator file, it says 10, so I'm thinking it's going to be 10, but then it runs and should only have 2 executors. Here's my second one. Okay, so that's all it's going to be, and that's because my data doesn't have the partitions. So just to note the relationship here between the partitions and the executors. So we're pretty much done with the Docker for desktop. In case I didn't mention it, before this runs, you have to run your setup. And this includes a setup for Docker for desktop. And if you look at the setup file, it's simply going to install your Spark operator. I'm using this one because it has a little fix. This demonstration does not use a port, so you could probably use the current one. But it does 2 things that are important. It installs the Spark operator, and then installs or creates a service account. So both of those are important, and that works. And just a note about it, if I run it without a parameter, then it's going to do Docker for desktop. And if I put in cloud, it'll do the current, if I give it some parameter instead of switching to Docker for desktop, it'll run your current Kubernetes cluster. And that'll be important next when we go to the cloud. We don't want to install the setup on our local computer. We're going to install it on the cloud. So we're going to run setup with the cloud. So do something like this. And it won't change to a different, it won't change to the Docker for desktop. So, all right, so let's give it a try. Let's see if we can run it now. Same idea, but using deploying to the cloud. Deploying to the Google Kubernetes engine or any sort of cloud takes a few more steps. So here's some of the things that have to happen in this case for the Google Cloud. I'm going to log into the Google Cloud Platform. I'm going to create a project if it's not already created. In this case, I've already got one created. See a prior video on how to make a new project, which is really not much to it. There's a drop down, a new project. Then within PyCharm or VS Code, if you're running VS Code, I'm going to use the Cloud Code plugin to connect, to log into the platform. And once I've done that, I'm going to go through the steps, and I'm going to initiate the steps of creating a cluster from the plugin. You could also do it directly from the cloud. Once that cluster is created, then I'm going to go ahead and run my setup program to deploy my operator and also create a service account. Once that's done, I'm going to make an artifact repository. This is for my for my Docker image. And I don't have to do this on Docker for Desktop because Docker for Desktop comes with a registry built in, but I have to do it for my cloud setup. So I'm going to do a cloud repository. Then the cloud repository is going to hold my image, and so I need to specify in the configuration files what image path it should use to deploy to that cloud cluster. So it's not going to deploy from my Docker for Desktop, it's going to deploy from the artifact repository on the cloud. So I have to update my files appropriately. And then I press the play button and it all works, hopefully. All right, so let's give this a go. Okay, so I'm at my Google Cloud dashboard, and I've selected this project I created previously. If I want to do a new project, I just grab this drop down here and say new project. There's really not much to it. New project, and go through the steps. I'm not going to do that. Already got one. I'm just going to use this one I have from before. And it's called Data Demo 01. And when I create my project, I tried to make sure that the project name and the ID are the same. It just makes life easy. Of course, if you don't do that, it'll give you some random number. So I've got my project created. So that was step one in my to-do list. Now I'm going to log in from PyCharm to this project. So I'm in PyCharm. Let's see if I can log in here. Let me go to Tools and Cloud Code, and there I'm going to go ahead and sign into my Google platform. Now I'm authenticated from my PyCharm to my Google Cloud. Next step, I want to create a cluster, which I'm going to use to work with. At the upper right, there's some buttons here with the Kubernetes Explorer. I'm going to hit the plus and select my project. Because I'm logged in, it knows about my project. I'm going to select it. Then I have some things I can do here. You can do the autopilot cluster. I'm not going to do that because I want to demonstrate things. So I'm going to go ahead and create a new GKE cluster. So I'm going to select that, and it's going to have me go to the cloud. I'll give my cluster a name. And I can go through and specify all the details here on the left. First time, it's probably a good idea to go ahead and follow their advice here about using my first cluster as a startup. So let's go ahead and do that. My first cluster, affordable. I'm going to go ahead and customize it though. You can see some of the items here that they do. I'm going to go ahead and customize it. So it's my first cluster. I'm going to give it some name. I'm going to choose a zone. For me, I'm in the east. I'm going to leave the release as it is. You can choose different images. You've got different memory configurations. All of these things are also found over here on the left. This is just a wizard, to help you get it started. It has 1 CPU and 2 gigs of memory. That might be a little bit small. So I'll do a little bit more, 4 gigs of memory. I'm not going to enable auto scaler and these other options, which can end up being expensive. After some time, your cluster will be created, as can be seen here. In my case, I had a few times where the cluster could not be created because there were not enough resources. That's what you can see here. Unfortunately, it took about 30 minutes each time, and it happened to me about 3 times, which is very unusual. In any case, what you can do is simply select a different zone. So I selected Eastern zone for the most part, but at the end I got it to work with the Southern zone. So if you have some issue with the creation of the cluster, then select a different zone. Once the cluster is created, then we can go on to do the rest of our steps. We want to ensure that Spark operator is installed and also that the Spark service account is available. Then we also need to create an artifact registry. So let's do those. So first I can select my cluster. Once I've selected the cluster, then I can connect to it. And I've got a couple choices here. And one is that I can install onto my own computer in my terminal the Google Cloud SDK. So if I did that, you can download it here, install G-Cloud CLI for command line interface. And there's different ways to install it. And if I'm installing on my Windows system for Linux, I'll select this, and you can see the different installs for Mac and Windows and so forth. And for the Windows system, essentially run these commands to install it. So it's not that big a deal. Once you have that installed, then you can copy this command. If you look at this command, it's going to run Google Cloud. That's the command line interface, containers, clusters, and then it's going to get their credentials. And in this case, my cluster is this data demo cluster 1. And then the rest of it came when I created the cluster. It's a zone south, as I mentioned, that worked, and there's the name of the project. So I can copy that and then paste it into my terminal. And it'll connect this terminal to the remote computer. Once I've run the command, then you can see that I've now have the current context is this remote desktop. The remote cluster. And then my kube control commands will then execute not against my local desktop cluster, but instead this remote cluster. I've got to go through the install of this plugin, and it should work. So this is one way in which I can communicate from my local computer to my remote cluster. To simplify this demonstration, I'm going to do a way that you can use the cloud. So let's look at the second way of doing it, the cloud console here, which is running this cloud shell. This is what I meant to say. So this is going to start up a terminal in the cloud, and that's the same as if I had, well, I don't have it here, but there's a terminal normally. When I open up a cluster, there's usually a way to connect using a terminal. It'll open up essentially this, and this is what you see here. I've got in my browser, I've got a terminal, and it went ahead and used that same command that I had before, but now not on my computer. It's on the remote terminal. Hit the return key, and it'll ask me to authorize. So now this terminal in the cloud, I'm able to use it to connect to my cluster. So one of the next steps I want to do is I want to run my setup, which is going to install my cloud, my Spark operator in my Google Kubernetes engine in the cloud. It'll also install the Spark service account. So I want to run it in this terminal here, or as I mentioned before, I could also run the setup in on my computer. So I could run it here, and because I'm connected to my remote computer, if I ran setup, it would run, and I'd say cloud, it would run on the cloud Google Kubernetes engine. But I want to show this other way to do it, because maybe you don't want to have your own terminal, and you have to install the Google Cloud SDK. So I'm in this cloud terminal, and I want to run that setup program. And if I look at kube control, I get context. Now the command is kube control config get context. And if I do that, you can see that I'm connected to my proper cluster, and now I can run a command on that. So how to run my command? Well, what I want to do is I want to use this option here in the cloud to upload some files. And I could upload a whole project and use all of the cloud tools, and not even use PyCharm or any of my local resources. I can do it all in the cloud, and have another video on that. But in this case, I'm just going to upload one file and run setup there just to show how it can be done. So I'm going to choose files and then upload that file. So I'll select the setup. I'll go ahead and upload it. It's going to transfer it from my home computer to the remote computer. I can list it. There's some other things I uploaded before and other examples. But right now I'm just going to use this setup.sh. Need to change the permissions, change mode, plus execute. And I forgot to upload the Spark operator, which I've been using. So I'll upload that. Then after it completes, it gives you some information. Because I ran this once before, the Spark account is already available. So now I can list my information on my cluster. And you can see I have my Spark operator, which has been uploaded. Now I can go back to my PyCharm and make sure I've connected to that remote cluster. And this time, having ran through the process to create the cluster, I'm connected to the project. Now I can go ahead and choose OK. Once I do, then I'll have it in the Explorer here. Unfortunately, I've noticed it takes a little time, so you might have to refresh. It might time out, give you an error message, refresh a couple times, and eventually it'll show up. So this is my cluster in the cloud. It has no workloads at this point, but it does have the 3 nodes that were created when I created the cluster, and it should have the Spark operator. So it seems to be working properly. So next, let's see if we can deploy our application. So I'm going to go ahead and select the same one I did before, Spark Hello, press play, and this time it should deploy to the remote cluster. I want to make sure, so I'm going to look at my edit configurations. And it looks like it's in the proper place. It has this cluster that I've been creating. But one thing I haven't done yet is choose an artifact repository, because it's going to build my image. And it's going to need to have that image go somewhere and then be referenced in the Spark operator. So next on my list, things to do is to create the artifact repository and make sure everything is properly referenced. So let's do that next. Back to the Google Cloud, I'm going to look at my list for the artifact repository. And I'm going to enable it and then create an artifact repository. Let's go ahead and create our repository. Give it a name. Going to be a Docker repository, and I want to select the same region I had before when I created my project. I've selected the South region, which is the same as the project, and I'll go ahead and create. Now that the project repository has been created, I'm going to look into it, so I'm going to select it. And I want to note the path here to my repository. So here's my project name in the second spot, and then the repository name in the third spot, and here's where it's located. And I'm going to select that path and copy it by selecting the copy button. Now I'm going to configure my runtime configuration to make sure it properly uses that repository. And I'm looking at this Spark Hello, and now I have a choice to choose the artifact repository. And I could have pasted, but it's smart enough to know that this is the path. So I'm good to go. I'm going to choose OK. The scaffold file refers to the image, and here's my image name. And you can see that it's an artifact and an image. But this needs to be the path to the repository followed by my image name. So when I copied it from the web, I pasted it into this scaffold file. Now that matches up with the repository path and then the name of my image. When you try to run the application or build it initially, pressing the play button, it will go through the process of building it. It takes a little time. It's also going to push the image from your computer where it's building it to the cloud. It's going to push it to the cloud artifact repository. And if you haven't added permissions to your project, which is unlikely for the artifact registry, then you'll get this nice error message, which is helpful in that it's going to tell you where to go to add permissions to the artifact repository. So just go ahead and click the button, and that way you don't have to search through the Google Cloud, searching for the artifact repository credentials. Instead, it'll give me this link here. Just click on the link. When I get the error message, it's going to go right to that link for the my project and allow me then to create the credentials for it. So I'll just go ahead and click on the credentials. And if you looked at my video on Google Dataproc and using that API, it's the same process. So just a reminder of what we did for the Google Cloud Dataproc API. We clicked on the API, selecting Create Credentials, and we walked through a few steps where we selected the application data and enable the credentials. You can go through and search for credentials as well, but I just find it easier. In this case, I'm enabling the credentials for the registry, and it'll take me right there. If I select the error message inside the Google Cloud plugin. So I select that. It's going to take me to my credentials where I can enter them. So let's go ahead and create our credentials. After we've added our credentials for the artifact registry, let's go ahead and press the play button again and see what happens. So I'm going to press the run button. And the first time that this runs, it's going to take a long time because it builds the Docker image and then pushes it from your local computer to the remote registry. It takes quite a long time. In fact, you might get some timeouts and have to run it again. So be prepared to run it maybe a couple times because it's so much that it can have a timeout. But next up, I'm anticipating an error here, which I left in on purpose. So I'm going to right-click on my Spark Hello driver and describe it. let's go see what kind of mistake might be made. So this is a very common mistake, this error image pool. You can see all sorts of concerns about this on Stack Overflow. It's very common. So let's go back and see what we're supposed to do. So as I mentioned before, we did our Spark operator. We created our registry with our credentials, and then we modified, well, it says here the YAML files. And we're supposed to set it so that the YAML files all point to the registry that we created. And as you recall, we're looking at the one here in the scaffold. It points to this registry. Right, but is that the only YAML file I have? So I'm going to copy this. And I'm going to look at this other YAML file. So the first one is scaffold. That builds the image and sends it to the registry. In this case, the registry is on Google Cloud. I'm going to look at the resource here, Spark Hello, and this is a Spark operator, and it also has a reference to the image. So I've got a couple places, the scaffold and the Spark operator. They both must reference the proper path to the registry and then the image. So this one was mistaken. It was not, I didn't edit it. So just a reminder back to this. You're going to have to edit all of the YAML files. And in this case, you've got one for scaffold and one for the Spark operator. All right, so let's see what happens when now that I've edited this. So I've got my Spark Hello YAML and my scaffold, and they both point to the same path. And just a reminder, that's that same registry I have when I stop this. When I edited my configuration for Spark Hello. So I'll look at this registry. So it's all the same registry, and then after that, the image name. So this time when I run, I hope, anticipate that it'll run. Now there's a couple issues that will come up. Once again, there's a pretty big image, and the image has to be sent to each one of the nodes. So let's think about this. So the image is going to be retrieved from the registry and sent to each one of these nodes. The image is fairly big because it's a Linux description of a Linux operating system plus my files. So the first time this image gets pulled, it can go so slow, at least on the cheap computers I use on the Google Kubernetes engine, it goes so slow that this hello driver will time out. I ran this once, I paused it just so that we didn't have to wait for that. But what will happen is that the Spark driver typically will work, and one of the Spark executors works, and then you'll get a yellow indication warning on one of your executors as it takes some time to download that image to that executor, which is on one of the nodes. And it could be the first time, and it takes so much time that while it's while this driver is waiting, it times out, and then the driver gives up and just says, "I'm just, it's not going to work. I'm going to stop." So that can happen. So just be aware of that and just press the play button again. You can look at the run, and it'll have a log of what's going on and whether it's there's a problem or not. So I should have looked at the output, but it's all stopped. So let's stop this, and let's look at our description of our Spark operator here. And I think I have 10 executors here. So ideally, I have a fair amount of memory between these three nodes. Let's look at my program itself and see how many partitions I have. And I just changed it here. It's 20. So when I run it, I should have, I'll have 20 partitions, and they should get mapped over 10 executors. If there's that amount of memory, it should be there. So let's run it and see if we get a number of executors. If this program runs for a little bit, I'm anticipating to have a few more executors than 2. And why is that? That's because originally when I deployed this, I had 2 for partitions here. I changed it to 20. And if I look at my executor, I have 10 executors here, so it all should work. And we'll find out this doesn't work here. And why is that? Well, if you look at this detail here, it has to do with this image pool policy. I have changed my code. I changed my partitions from 2 to 20, but then the image is not getting updated on the remote registry. And you can actually look at the date and go to the registry. I just want to show first why this is an issue. So on Docker for desktop, you don't want to have this image pool policy as always. It just doesn't work, at least when I've used it. So what I want to do instead is, because I'm not working on Docker for desktop, I do want to have the image pool, meaning the newest image from my change. That is, I changed my partitions here from 2 to 20. So now I've got lots of partitions, and presumably I have enough executors that I have 10 running. So it's helpful to understand sort of what's going on, and because I have partitions and executors, I'm expecting to have these pods show up here for my executors. But because the image policy was not always, it didn't update my image on the remote registry. So now I've changed my image policy, which I comment out for Docker for desktop, but now I'm going to deploy it to the remote Google registry. And so now let's give this a try. I'm going to do my play button again to execute my run configuration. And now that my image is policy is always get the newest one, it should send over the newest image. And that should allow it to see that I've changed my partitions from 2 previously now to 20. And with that and the combination I've got down here, executors up to 10, I should see over here my pods. I get my driver going, and I should have 1 executor and then a couple. That's what I had before. The first 2 would probably be pretty quick because the image have been pooled because I've run 2 before. But then thereafter, I should get up to 10 if I have enough memory for it. So if we pull back, we can see that we have, in fact, we've got 10 executors. Okay, so it seems like it's going to work. Also, if I look at my service URLs, I can click on this, and it already does port forwarding for me, which is really nice. I can even look at my environment here, and hopefully before this finishes, and see the number of executors. So these executors are the ones that are in my environment, and it should end up having 20. What do I only have 5 now? But so I can go back and see my job. Is it stopped? Maybe because it stopped. Yeah, all right, stopped. It wasn't fast enough, and it removed all the executors before I was done and finished before it was done. That's why I couldn't get to it. So it went ahead and finished, and should be able to see the output. Did I guess maybe I didn't stream it, so maybe I should run it again. Okay, so let's try it again and see if I can be a little bit quicker. Okay, so I'll press the play button. I think we saw previously there was 10 executors here. I'm not going to spend too much time on that. I want to get right to the Spark UI service URL so I can see what's going on. It takes a little time, but it does get deployed. Okay, it's going. So now let's go look at my service URL. And it does take a little time. The executor has to start up, and the Spark has to be started up within that. So it's not quite ready yet. I'm just going to refresh. It hasn't started the Spark job yet. So now I refresh, and it shows. And you can see just the driver. So this is sort of a different interface looking into it. So we'll go back to here. I've got a couple going. So back to my Spark UI, and I should start to see the executor show up here. It's a little bit slower. It's 4, 5. Maybe this 5 doesn't work. So let's go describe this. Yeah, okay, that's interesting. So you can see what goes on. I end up with 5 total. That's all my memory allows, and that's why it stopped at 5 when I was in the user interface. And why is that? Well, I don't have enough memory for it. So there is a relationship between your memory you have in your nodes and how much you can run here in my Spark operator. I say a maximum of 10, but in fact it's really maximum of 5. I could change this for this particular cluster, setting my Spark operator to match the cluster I have set up. Just run it one more time. Just remind us where we are. We went through all the steps here. I wanted to make sure that we edited all the YAML files, not just the scaffold, but also the Spark operator to have the proper reference to the image. That's very important. Otherwise, you get a pool error. We submitted our job. It seems to be working. Note that the first time you submit it, it can take a long time, and you might get a timeout and have to press the submit button again. And thereafter, because the nodes will already have a cached copy of that image, then everything should work a little bit faster. This time it should work. All right, so we can look at the driver and see the results. Hopefully at the bottom here, it'll print out the result for Pi. Okay, it finally prints it out. So some notes in summary about all of this is that this image path is super important, and when you make your project and get a artifact registry, you're going to have to update your YAML files. The one that has the Spark operator, the one I'm looking at here, and also the scaffold. And if you're using cloud code, which I use, then you should also make sure that that repository is set properly. Once all that works, then hopefully it should run. The other thing to think about is this image pool policy. I comment it out when I'm running on Docker, and I uncomment it when I have a cloud configuration, so that we'll always update the image on the nodes, pulling it from the registry every time. So here we are, we're done. We went ahead and demonstrated how to run PySpark on Kubernetes. First running on Docker for desktop, which is pretty simple, and then running it on the Google Kubernetes engine, which requires a few steps, including creating a registry and getting permissions for that registry, and then updating your files, the scaffold and the Spark operator, to point to the registry where it's going to put your image. So again, I demonstrated deploying PySpark to Kubernetes on the desktop, pretty simple. And then a few more steps when we deploy it to Google Kubernetes engine. This can all be done at the command line if you'd like to. It's a few more steps. I find it easier just to press the play button using cloud code, and it does the build and the deployment properly. Plus you get a nice interface where you can right click and describe and so forth. So that's a demonstration of how to deploy your PySpark programs to a cluster, both local and remote. And I hope it works for you.